Hello everyone. In this video, I am going to take you through some algebra interesting questions. So please watch the entire video. It will help you a lot. Do not forget to like, share, subscribe, and comment if you want to. Number 1. If you come across this nature in the exam, first thing first, check the ratio of the exponents. So now if we check the ratio of the exponents, we are going to say 4 over 5. We divide it by 2 over 5. Now you'll notice that here the answer is 2. So if the ratio is 2:1, so that means this equation can be factorized as a quadratic trinomial. So now this is can be factorized as x squared minus 3x minus 4, because even here, if you can check the ratio of the exponents, if you say 2 divided by this one here, the answer is 2. So we can simple open 2 brackets here, and we are going to have x factors of 4 that we can subtract and get 3. Since 4 is negative, it is 4 and 1. So it is minus and plus. So even here, you can do the same. However, now, you are not going to have x to the exponent 1, because your exponent here is 2 over 5. So we will have x to the exponent 2 over 5, x to the exponent 2 over 5. Remember, with this one, we take the middle term here, right, and say x to the exponent 1, x to the exponent 1. In this case, it will be 2 over 5. And then the factors of 4 that we can subtract and get 3, it is 4 and 1. So we have minus and plus. This is equal to 0. And then from here, we have the product, which is equal to 0. So that symbol means x to the exponent 2 over 5 is equal to 4, or x to the exponent 2 over 5 is equal to negative 1. Now, here we need to solve for x, so that means we need to multiply the exponent by its reciprocal. So we are going to have x to the exponent 2 over 5, and then we multiply by reciprocal, which is 5 over 2. This is equal to 4 is the same as 2 to the exponent 2, and then even here we multiply by reciprocal of 2 over 5, which will be what? Which will be 5 over 2. Now, here we are going to remain with x is equal to, now 2 and 2, they will cancel out, and then 2 to the exponent 5 is the same as 32. And then we have or x to the exponent 2 over 5 is equal to negative 1. Again, we multiply by a reciprocal on both sides. So we are going to have x is equal to, now, this will be negative 1 to the exponent 2 over 5. Now, if you check this one here, this is the same as having the square root of negative 1 to the exponent 5. So, which will be non-real. So with this one, there will be no solution. Then we are done with number 1. So the only solution here is x is equal to 32. And then we are done with this one. Let's move to number 2. Number 2, we are given 2 to the exponent x plus 2 plus 7 root 2 to the exponent x is equal to 2. So with this one, there are so many options that can be used to solve this one. But let me choose one. So let me split this first. So this is the same as, or it can be written as 2 to the exponent x multiplied by 2 to the exponent 2 using the laws of exponents, plus 7 root 2 to the exponent x is equal to 2. And then this is the same as 4 multiplied by 2 to the exponent x plus 7 And then we have 2 to the exponent x is equal to what? Is equal to 2. So from here, I can say let 2 to the exponent x equal to k. Let 2 to the exponent x equal to k. So my equation will be now 4k plus 7 root k is equal to 2. Now again, I can see that I have a square root, so that means I need to separate. So anything that is not attached to a square root or anything that is not under the square root must be transposed. So here I'm going to have 4k minus 2 is equal to, and then I transpose this root with 7, it's 7 root k. And then from here, I can square on both sides. Remember, when you square on both sides, you square everything. So if I square on both sides, okay, let me square this, square that. You can see that I am squaring everything. Now, we are going to have, remember squared means the bracket exactly as it is repeated twice. So I'm going to have 16k squared minus 16k and then plus 4. This is equal to, remember, if they is squared again, the negative will always go away. Negative 7 multiplied by negative 7, it is positive 49. And then squared will remove the square root, so it will be 49. It will be 49k. Now from here, I can see that the exponent, the highest exponent is 2. So my equation needs to be written in a standard form. If I write this equation in a standard form, I am going to have 16k squared. Okay. And then if I transpose 49, I'm going to have minus 65k. And then plus 4, this is equal to 0. Remember, if the coefficient of k squared is not 1, sometimes it is very challenging to factorize. But we can use the quadratic formula. So in the quadratic formula, you are going to get k is equal to 1 over 16, or you are going to get k is equal to 4. So now with this one, we can multiply everything by 16. This is 16k, and then transpose 1 minus 1 is equal to 0. And then this one, if you transpose 4, it will be k minus 4 is equal to 0. That means our factors are 16k minus 1, and then k minus 4 is equal to 0. So from here, we know that k is equal to 1 over 16, or k is equal to 4. Now remember, we are not solving for k here, we are solving for x. So now we are going to take these k values and substitute there where there is k. There is our k. We said let 2 to the exponent x equal to k. So now we start. So we are going to have 2 to the exponent x is equal to 1 over 16 is the same as 2 to the exponent minus 4. So x is equal to negative 4, or 2 to the exponent x. 4 is the same as 2 to the exponent 2. So x is equal to what? Positive. X is equal to positive 2. Now we need to check if our answers are both valid. So we take these x values that we got here. We take x is equal to negative 4, and then we substitute where there is x. Now you'll realize that if you put negative 4, we do get positive 2. So that means this answer is correct. But now if we substitute 2, where there is, we are not getting 2. So that means x is not equal to 2. The only value that is applicable is x is equal to negative 4. And then let me move to the next one. So number 3, very interesting again. So number 3, again, we are given these 3 terms, and then before I do anything, let me split this, because I can see that I can still split this. So this equation can be written as 3 to the exponent x minus 3 to the exponent 1 times 3 to the exponent negative x minus 2 is equal to 0. Now, if you check first 2 terms, if you check the exponents, unfortunately, if you say x divided by negative x, the answer is not 2. So for now, this is not quadratic. But if again we try to take out the common factor, unfortunately, again, this x is positive, this one is negative, so there is no common factor here. So, but we can write this as, this is 3 to the exponent x minus 3, and then we take this down, it will be 3 to the exponent positive x minus 2. This is equal to what? This is equal to 0. And then from here now, we can see that we have 3 to the exponent x and 3 to the exponent x. We can now say let 3 to the exponent x equal to what? Equal to k. Now you will then notice that we have k minus 3 over k minus 2 is equal to what? Is equal to 0. We multiply everything by LCD. Our LCD is k, so we are going to multiply each and every term by k. So if I multiply k with k, I am going to have k squared. If I multiply negative 3 over k plus k, I will remain with negative 3. If I multiply negative 2 by k, I will have minus 2k. This is equal to 0. I can see that the highest exponent here is 2. My equation must be written in a standard form. Ax squared plus bx plus c is equal to 0. So if I write this in a standard form, I am going to have k squared minus 2k minus 3 is equal to 0. And then from here, I can factorize. I am looking for factors of 3 that I will subtract and get 2. So the factors of 3 that I will subtract and get 2, we have k are 3 and 1. So this one is what? It is negative. It will go with the middle term. This one is positive. So that means k is equal to 3, or k is equal to negative 1. But I am not looking for k. I want to solve for x. Now I am going to have 3 to the exponent x is equal to 3 to the exponent 1, so x is equal to 1. This is my first solution. And then here I will have 3 to the exponent x is equal to negative 1. So remember, 3 to the exponent x is an exponential function, and then it is greater than 0. For x is an element of all real numbers, so it can never be equal to 1. So that means here we have no solution. So the only solution that we have is x is equal to 1. So this equation has only one solution, which is x is equal to 1. Let me move to number 4. Number 4, almost the same as number 3, but it is a little bit different. Show that 2 to the exponent 2x plus 1 plus 7 times 2 to the exponent x minus 4 has only one solution. So now here that means if I solve this equation, I will only get one solution. So let me see. Now this can be written as, this is 2 to the exponent 2x, and then multiply by what? Multiply by 2 to the exponent 1, and then plus 7 multiplied by 2 to the exponent x minus 4. This is equal to what? This is equal to 0. And then from here I can I can rewrite this as 2 to the exponent 1 is the same as 2, so we have 2, and then this is 2 to the exponent x all squared, because 2 multiplied by x is the same as 2x, and then plus 7 multiplied by 2 to the exponent x minus 4. This is equal to 0. Now from here I can again say let 2 to the exponent x equal to k. So I am going to have 2, and then this one will be k squared plus 7 multiplied by 2, not multiplied by 2, but multiplied by k, because 2 to the exponent x is now k, minus 4. This is equal to 0. And then from here I can factorize. So remember, we said if you are not comfortable with factorization, you can always use quadratic formula. So you will realize that if you use quadratic formula, you will get k is equal to 1 over 2, or k is equal to negative 4. So that means we multiply by 2 everything here, you'll have 2k, and then transpose 1 minus 1 is equal to 0. Here you'll have k plus 4 is equal to 0. So that means the factors here are you have 2k minus 1, and then you have k plus 4. This is equal to what? This is equal to 0. And then from here we can see that this will be k is equal to 1 over 2, or k is equal to negative 4. And then now remember, we are not looking for k. And then from here we have 2 to the exponent x is equal to 2 to the exponent minus 1. Remember, 1 over 2 is the same as 2 to the exponent negative 1. So therefore x is equal to negative 1, or we have 2 to the exponent x is equal to negative 4. So again, remember the exponential function, 2 to the exponent x is an increasing exponential function that is above 0 for all values of x. So the range is y is. Number 5, here we have square root of 2x minus 2 minus square root of 7 minus 2x is equal to 1. So with this one, it is very difficult to separate. Number 5, we are given the square root of 2x minus 2 minus square root of 7 minus 2x is equal to 1. So here it is impossible to separate without having square roots on both sides. So I am going to separate, but on both sides we are going to have a square root, because it is more difficult to square on both sides while we have 2 square roots on the left. So I am going to take this one to my right, and then I will have square root of 2x minus 2 is equal to 1 plus square root of 7 minus 2x. And then now we can square on both sides. So if I square on both sides, okay, let me square on both sides. squared, we square everything squared. So I am going to have this and that will reverse each other. So we are going to have 2x minus 2 is equal to, now we have 1 plus square root of 7 minus 2x. Remember, squared means the bracket exactly as it is repeated twice. So we have 7 minus 2x. And then here we are going to remove the brackets again. So this is the same as 2x minus 2 is equal to, now we start. 1 times 1 is the same as 1. 1 multiplied by square root of 7 minus 2x, it will be plus square root of 7 minus 2x. Square root of 7 minus 2x multiplied by 1, it will be plus square root of 7 minus 2x. And then remember, the square root of a times the square root of a, the answer is always a. Square root of 10 times the square root of 10, the answer is always 10. So even the square root of 7 minus 2x times the square root of 7 minus 2x, the answer is 7 minus 2x. And then from here, I am going to transpose everything that is not under the square root or not attached to a square root. So if I transpose 2, if I transpose 2x, I am going to have 4x, and then negative 2 minus 1 minus 7, that is minus 10 is equal to. So these are like terms. So the square root of 7 minus 2x plus another square root of 7 minus 2x, it will be 2 square root of 7 minus 2x. And then from here, we can see that 2 is common throughout. There is 2 in 2, there is 2 in 10, there is 2 in 4. We can divide everything by 2. If I divide everything by 2, I will remain with 2x minus 5 is equal to square root of 7 minus 2x. And then again, I want to get rid of this square root. So I am going to square on both sides. Squared. Now, if I square on both sides, I am going to have a 4x squared minus 20x plus 25. This is equal to 7 minus 2x, because squared will cancel the square root. And then from here, we can see that the highest exponent is 2. We need to write our equation in the form of ax squared plus bx plus c is equal to 0. So this will be 4x squared, and then now minus 18x, and then 25 minus 7, it is plus 18. This is equal to what? This is equal to 0. And then we divide everything by 2, because 2 is common throughout. So if I divide everything by 2, I am going to have 2x squared minus 9x plus 9 is equal to 0. Now we can see that the coefficient of x squared is not 1. So it is better to use the quadratic formula. If I use the quadratic formula here, I will get x is equal to 3, or x is equal to 3 over 2. And then you can transpose this 3. You will have x minus 3 is equal to 0 here. We multiply by 2 first. It will be 2x. Transpose 3 minus 3 is equal to 0. So that means your factors here will be 2x minus 3 as well as x minus 3 is equal to what? Is equal to 0. So if we solve this, our x is equal to 3 over 2, or x is equal to 3. So now we need to check if these values are both valid or not. So we need to check we are going to substitute this in the original equation. So we need to check. So, and then if we check here, you will then realize that if you substitute, if you put this 3/2, left hand side is not equal to right hand side. But if you put 3, you will notice that right hand side is equal to left hand side. So you need to say x is never equal to 3/2. So the only solution here, we have x is equal to 3 only. That is your only answer for number 5. Let's move to number 6. Number 6, we are dealing with fractions. There are also roots. So now we have the square root. We have another square root here as a denominator. You can see that square root of x plus 5 is your LCD. So here I can multiply everything by square root of x plus 5 to get rid of this. Now if I multiply everything by square root of x plus 5, so square root of x plus 5 times square root of x plus 5, it will give me x plus 5. Remember I said square root of a times square root of a, it is always a. Square root of c times square root of c, the answer is always c. So even the square root of x plus 5 times the square root of x plus 5, the answer will be x plus 5. And then plus 5 multiplied by square root of x plus 5, it will be 5 square root of x plus 5. This is equal to, and then if you multiply this term here, if you multiply this term by square root of x plus 5, x plus 5 and x plus 5 will cancel, and then you will remain with 14. And then here again, we need to separate anything that is not under the square root or anything that is not attached to a square root must be separated. So I am going to transpose 14. So if I transpose 14, I'm taking 14 to my left. I'm going to have x minus 9 is equal to, and then transpose this, negative 5 root x plus 5. Now we need to square on both sides. So we want to get rid of the square root, so we need to square on both sides. So if I square on both sides here, I am going to have x squared minus 18x and then plus 81. So yes, 9 squared is 81. This is equal to, remember, squared. This negative will always go away. So it is 25 into x plus 5. Now, remove the brackets again. We have x squared minus 18x plus 81 is equal to 25x plus 125. And then transpose everything, take everything to my left so that the equation is written in a standard form. I will have x squared minus 18 minus 25 minus 18x minus 25x, that will be negative 43x. So this is negative 43x, and then 81 minus 125, this is negative 44. This is equal to what? This is equal to 0. And then now we are looking for factors of 44 that I will subtract and get 43. It is 44 and 1. So this is minus, this is plus, is equal to 0. And then again, we are going to have x is equal to 44 or x is equal to 1. Now, not 1. Here we get x is equal to minus 1. And then we need to check if these answers are valid or not. So we take this answer and then we substitute in the original. So now where there is x, we put 44. So if we put 44 where there's x, okay, let me substitute. So our answer is it okay? I think I am getting 12 if I'm not mistaken. If I put 44 there, and then now, so that means 44 is not my solution. So x here is not equal to 44. The only solution that gives me left hand side that is equal to right hand side, it is -1. So on my left I get a +7, even on my right I get +7. So x is equal to -1 is the only solution. So x is equal to -1 only. That is the only solution for number 6. Let's quickly move to number 7. Number 7, we are required to prove that this expression can never be negative for any value of x and y. So that means whatever value of x and y that you substitute in this equation, the answer is always positive. If you put +100, the answer is positive. If you put -100, the answer is positive. So any value of y on x that you put, it will always give you the positive answer. So now this equation here, okay, can be written as x squared minus 2xy and then plus y squared plus y squared. Remember, y squared plus y squared is the same as 2y squared. Why am I writing this equation like this? I want to create a perfect square. Now this part here can be written as x minus y all squared plus what? Plus y squared. Now you will notice that x minus y squared is greater than 0, is greater or equal to 0 for x. Y is an element of all real numbers, because as long as your exponent is an even number, you know that your answer is always positive or equal to 0. So it can never be negative. It can be 0 or positive. And then y squared also is greater than 0, is greater or equal to 0 for y is an element of all real numbers. Because of this squared again, whatever value that you put where there is y, the answer is always positive because the exponent is an even number. So now if you add two positive answers, the answer is always positive. So that means x minus y all squared plus y squared is greater or equal to 0 for x, y, and y is an element of all real numbers. So the answer here can never be negative. It will be greater or equal to 0 for x and y is an element of all real numbers. And then let's move to number 8. Number 8, we are solving an inequality. So this one, if we factorize here, we are looking for factors of 25 that we can add and get 10. So it is x, it will be 5 and 5. So plus and plus, this is greater than 0. Now, if you check here, we only have one critical value. So our critical value that we have is x is equal to minus 5. So if we try to draw our parabola, so our parabola will touch or will have only one root. So it will touch the x-axis at only one point. So it's okay. Here it's not even, I can't even shade here, it's not included. So it will be something like this, and then here is our parabola. So now you will realize that this parabola is above the line. We are looking for greater than 0, so above. So you can see that the parabola is above everywhere. This parabola is above everywhere, except at 0, because at 0 it is not at 0, at 5, except at -5, because here at -5 is not included. So the answer here will be x is an element of all real numbers. It is greater than 0 everywhere except at 5. So but x is never equal to -5, because -5 is not included. At -5 it is not greater than 0, but it is equal to 0. At -5 it is not greater than 0, but it is equal to 0. And then the next question, this one, if we use number line here, our number line will be, we have only one critical value, which is -5. Now the coefficient of x squared is positive, so we start with positive. The part where we are supposed to be putting negative is not here, because we only have one critical value, so it will be positive and positive. So the middle part is missing. Now you can see that where is positive. Remember, greater than 0 means positive, so here is your positive everywhere except at -5. So still the answer is x is an element of all real numbers. X is not equal to -5. 8.2. So with this one, we are given two functions here. This is the sum of two squares, and unfortunately we cannot factorize the sum of two squares. Multiplied by another function, the answer must be negative. So you can take this as f of x multiplied by g of x, and the answer must be less than 0. So that simply means one function must be negative and one function must be positive. But now this one here, if I were to draw this graph, we have a parabola that is concave up, that has a turning point at 0 and 1. So here is the minimum value at +1. So you can see that this graph is above the x-axis for all values of x. So x squared plus 1 is greater than 0 for x is an element of all real numbers. So that means the only function that can be negative is this one. So we are going to say, therefore, x minus 3 is the one that can be negative. So that means the solution for this is x is less than 3. So the solution here is x is less than 3. Now let's move to number 9. Number 9 is a little bit tricky again. Let me drink water a little bit. Find the range. We are given this equation. We are required to find the range. Remember, range. We are talking about y values where your function is possible. Where your function is possible or defined. So that is your range. Our focus is on y values. For this to be real, this must be real, or it must be possible, or it must be defined. Now, with this one, let's write this in the form of ax squared plus bx plus c first. How can we do that? We can cross multiply here. we are going to have x squared minus 4x plus 12 is equal to 4y minus 4y, and then minus what? It is minus this one, it should be 4x here, minus 4xy. Okay, so x squared minus 4x plus 12 is equal to 4y minus, and then 4xy. And then from here, we can transpose everything to the left. So we are going to have x squared minus 4x plus 4xy plus 12 minus 4y. This is equal to 0. Okay, now this is x squared. This can be written as minus, and then we can have 4 minus 4y, and then we take x out, so that it is x squared. It is ax squared minus bx, and then we have our c, which is 12 minus 4y. This is equal to 0. From here, we can see that we have our a. Our a is equal to 1. We have our b. Our b is negative 4 minus 4y. We have our c. Our c is equal to 12 minus 4y. And then now, remember, we are looking for values of y, so that this will be real, or this will be defined, where the graph is defined, or where our graph is possible. So now, for this to be real, our discriminant, b squared minus 4ac must be greater or equal to 0. So now, what is our b? It is negative into 4 minus 4y all squared minus 4. What is our a? Our a is 1. What is our c? Our c is 12 minus 4 minus 4y. This must be what? This must be greater or equal to 0 for this to be real. Okay, now from here, we can remove the brackets. So if I remove this bracket, remember squared. Squared will always take this negative away. And then this bracket is repeated twice. So it will give us 16 minus 4 multiplied by 4 is 16 times 2. So it will be 32y, and then plus 16y squared. And then if we remove this one, 4 multiplied by 1, it is 4. So here it will be minus 48, if I'm not mistaken, minus 48. And then if I multiply again, 4 and 4, it will be plus 16. It will be plus 16y. This is greater or equal to 0. And then here we need to add the like terms and write this in a standard form. So it will be 16y squared. Now we are going to have 16. Or let me start with negative 32 plus 16. It will be minus 16. It will be minus 16y. And then 16 minus, we have 16 minus 48. So if we subtract 16 and 48, it gives us a 32 again. So this will be negative 32 is greater or equal to, this is greater or equal to 0. And then from here, we can divide everything by 16. So we are going to have y squared minus y minus 2 is greater or equal to 0. And then we are looking for factors of 2 that we can subtract. It is 2 and 1 to get 1, so it minus and plus. This is greater or equal to 0. So again, we have our critical values. So our critical values are y is equal to 2 or y is equal to negative 1. And then now we need to conclude. Remember, here we are concluding an inequality. So we can draw a parabola that is concave up because the coefficient of y squared is positive. So here is my parabola. And then we have minus 1. And then here we have 2. Okay. So greater or equal to 0 above. So here is my above. Separate region, the answer will have an O. So we have y is less or equal to minus 1, or y is greater or equal to 2. So that is the range of this function. Y is less or equal to minus 1, or y is greater or equal to 2. Number 10, again, we are required to solve for x. Now, here again, we can see that we can start by splitting this one, and then this can be written as 3 to the exponent 2 tan of x minus 3 to the exponent tan of x multiplied by 3 to the exponent 1 is equal to 54. And then from here we have 3 tan of x, and then we can square this because tan x multiplied by 2 is the same as 2 tan of x minus 3 to the exponent 1 is the same as 3 multiplied by 3 to the exponent tan of x. And then if we transpose 54 minus 54, this is equal to 0. And then from here we can see that we have this 3 to the exponent tan of x, 3 to the exponent tan of x. We can just say let 3 to the exponent tan of x equal to k to simplify this. Now, this will be k squared minus 3k minus 54 is equal to 0. Now we have a quadratic equation. So it is written in the form of ax squared plus bx plus c. So we can look for factors of 54 that we can subtract and get 3. So the factors of 54 that we can subtract and get 3, it is 6 and 9. So we have 9, we have 6. The signs are different. The bigger number will correspond with the middle term. So we have minus, and then we have plus. So that means k is equal to 9, or k is equal to negative 6. But we are not solving for k. Remember, we want to solve for x. Remember, we said our k is 3 to the exponent tan of x. Now, we will then say 3 to the exponent tan of x is equal to what? Is equal to 9. Is the same as 3 to the exponent. Is the same as 3 to the exponent 2. And then, or 3 to the exponent tan of x is equal to negative 6. Remember, this is an exponential, so this one already, we know that it has no solution. And then, now, here we can see that the bases are the same, therefore exponents are equal. That means tan of x is equal to what? Is equal to 2. And then from this we can solve for x. So therefore our x is equal to arctan of 2 and then plus k multiplied by 180, where k is an element of integers. Now what is arctan of 2? So our x is equal to, so arctan of 2 is the same as 63,43 plus k multiplied by 180, where k is an element of integers. So here is your solution for this question. So our x is equal to 63,43 plus k multiplied by 180, where k is an element of integers. Let's move to number 11. So we have 2 to the exponent 2 sine squared x, and then minus 5 multiplied by 2. So we can change, this is a double angle. We can change this double angle. So since we already have sine here, we will choose the one that has sine. So we can change cos 2x and write cos 2x as 1 minus 2 sine squared x. And then if I transpose 3, I will have plus 3. This is equal to 0. Now I can apply the laws of exponents and split this. So if I split this, I'm going to have 2 to the exponent 2 sine squared x minus 5 multiplied by 2 to the exponent 1 multiplied by 2 to the exponent negative 2 sine squared x, and then plus what? Plus 3. This is equal to 0. And then from here, you can see that there is no way that you will take out the common factor. This one is negative and this one is positive. So this can be written as this is 2 sine squared of x, and then 2 multiplied by 5 is 10, so it is minus 10 all over 2, and then now my exponent will be positive, and then 2 sine squared of x, and then plus what? Plus 3. This is equal to 0. And then from here, we can let these equal to k. So we will then now say let 2 to the exponent 2 sine squared x equal to k. So if we let this equal to k, we are going to have a k minus 10 over k plus 3 is equal to 0. And then here we can multiply everything by our LCD, which is k. Now multiply everything by k. What is k times k? It is k squared. What is negative 10 over k times k? It will be minus 10. And then 3 times k, it will be plus 3k. This is equal to 0. So write this in a standard form. So it will be k squared plus 3k minus 10 is equal to 0. Now, I am looking for factors of 10 that I will subtract and get 3. So factors of 10 that I will subtract and get 3 are 5 and 2. So we have 5 and 2. Signs are different. Bigger number will correspond with the middle term. So it's a plus and minus is equal to 0. So that means a k is equal to, our k is equal to negative 5, or our k is equal to 2. But now we are not solving for k. We are solving for x. Now we are going to say therefore, therefore 2 to the exponent 2 sine squared x is equal to negative 5. So this one has no solution. Or 2 to the exponent 2 sine squared x is equal to what? Is equal to 2 to the exponent 1. Now we can see that the bases are the same. So if the bases are the same, exponents are equal. So we are going to have therefore 2 sine squared x is equal to what? Is equal to 1. Now, I am going to divide by 2 on both sides and then put a square root on both sides. And then I will remain with sine x is equal to 1 over root 2, or root 2 over 2. Now, we can see that here we have general solution for sine. So that means our x here, our x is equal to arc sine of 1 over root 2. It is 45 plus k multiplied by 360. The k is an element of integers. Remember, for sine we have 2 solutions. And then we will say or x is equal to 180 minus 45. So 180 minus 45, it is 135 plus k multiplied by 360, where k is an element of integers. And then we have solved for x. So x is equal to this, or x is equal to that. Question number 12, which is the last question. We are required to solve for x and y simultaneously. So first thing first, we need to make sure that we make y or x subjects of the formula. So now, from our equation number 1, we have equation 1. We also have equation number 2. From equation number 1, it is very easy to make x or y subjects of the formula. First thing first, we need to change this 16. 16 can be written as 2 to the exponent 4. But because we have 1 over 16, it will be 2 y minus 3x is equal to 2 to the exponent. Because of this 1 over, it will be negative. It will be negative 4. Now from here, we have the same bases. Therefore, exponents will be equal. So our y will be y minus 3x is equal to negative 4. And then from here we have y is equal to transpose 3x. It will be 3x minus 4. So we can say this is our equation number 3. So our y is now a subject of the formula. So we are going to substitute this equation number 3 into equation number 2. So we are going to sub equation number 3 into equation number 2. So where there is y, we are going to replace y with 3x minus 4. So now if we do that, now we have x squared plus x. Now our y is what? Our y is 3x minus 4. This is equal to 24. And then from here we can remove the brackets. So we have x squared plus 3x squared minus 4x transpose 24 minus 24. This is equal to 0. And then from here we can add the 2. So we have 4x squared minus 4x minus 24. This is equal to 0. Our equation can be simplified because 4 is common throughout. There is 4 in 4, there is 4 in 24. We can divide everything by 4. So if we divide everything by 4, we'll have x squared minus x minus 6. This is equal to 0. Now, we are looking for factors of 6 that we will subtract and get 1. Factors of 6 that we will subtract and get 1, it will be 3 and 2. So we have 3, we have 2. 6 is negative, so the signs are different. So the bigger number will correspond with the middle term. So this is minus, this is plus. So therefore, our x is equal to positive 3, or our x is equal to negative 2. Now we do have our x. We can now calculate the corresponding y value. So to calculate the corresponding y value, we take these x values and substitute in equation number 3. So y is equal to 3 multiplied by, what is our x? 3. And then minus 4. We have 9 minus 4, which will be 5. Or y is equal to 3 multiplied by negative 2, and then minus 4. And then this will be negative 6 minus 4. What is negative 6 minus 4? It will be minus 10. So we have solved for x and y simultaneously. And then we are done with these questions. So also there is part 1 of algebra. So this is part 2, where I put some challenging questions. Please do not forget to share as much as you can. Subscribe. If you want to comment, please also comment. Thank you very much for watching.